completing the square can be a bit of work. That's where the quadratic formula comes in. The quadratic formula is a shortcut that helps us find the roots for any quadratic. And guess what? It actually comes from completing the square. So let's begin by deriving the quadratic formula. To derive the quadratic formula, we're really just completing the square for a general quadratic equation. This is the start of all quadratics. ax squared plus bx plus c equals 0. A is a constant that is a coefficient of x squared, b is a constant that is a coefficient of x, and c is a constant. To begin completing the square, we need to isolate x. We can do this by subtracting c from both sides. Now we need to make sure that x squared has no coefficient, so we'll have to get rid of the a. And how can we do this? We can divide everything by a. Now x squared has a coefficient of 1. Now, what's the next step to completing the square? First, we take the coefficient of x, b over a. Then we take half of this, b over 2a, and square it. This gives us b squared over 4a squared. Next, we add this to both sides. On the right, to simplify, we need a common denominator. The denominator of negative c over a is a. In order to add this to b squared over 4a squared, we need to make the denominator 4a squared. So if we multiply negative c over a by 4a over 4a, now we get negative 4ac over 4a squared. And now since we have the common denominator, we can just combine them. And let's move b squared to the front. This gives us b squared minus 4ac over 4a squared. Now on the left, we just need to complete the square. We know that the square will just be x plus half the coefficient squared. And since the coefficient of x is b over a, half of b over a would just be b over 2a, so the left can be rewritten as x plus b over 2a squared. So we've completed the square. Now we need to solve for x. To begin, we need to get rid of the square. We can do this by taking the square root of both sides. The square root of a square cancels out. On the right, we know that the square root of a fraction is the same as the square root of the numerator over the square root of the denominator, so we can simplify this a little bit. The square root of the denominator is the square root of 4a squared, which is just 2a. And let's not forget to take both the positive and negative roots of the square root. So now, our equation is x plus b over 2a equals plus minus the square root of b squared minus 4ac over 2a. And now to solve for x, we just need to subtract b over 2a from both sides. Now on the right, since we share a common denominator, we can combine the numerators. And this is the quadratic formula. Before we see this powerful formula in action, I want you to look at the expression under the square root, b squared minus 4ac. This is called the discriminant, and can tell us whether or not a quadratic has real solutions. As you know, the square roots of negative numbers aren't real numbers, they're imaginary numbers. So since we're dealing with the square root of b squared minus 4ac, the discriminant b squared minus 4ac must be greater than or equal to 0 in order for the quadratic to have a real solution. Alright, now let's see the quadratic formula in action. How can we use the quadratic formula to find the roots of this quadratic? First, we need to find our variables. A is 2, the coefficient of x squared, b is 5, the coefficient of x, and c is our constant, negative 3. Now, we just put these values into the quadratic formula. And let's first simplify the discriminant. 5 squared is 25, and next multiplying, 4 times 2 is 8, times negative 3 is negative 24. Minus negative 24 is the same as adding 24, so the discriminant is 25 plus 24, and this is 49. And since we're taking the square root, we know the square root of 49 is just 7. And the denominator, 2 times 2, is 4. So x equals negative 5 plus minus 7 over 4. And now we can simplify. Negative 5 plus 7 is 2, and 2 over 4 is 1/2. Negative 5 minus 7 is negative 12. Negative 12 over 4 is negative 3. So our roots are negative 3 and 1/2. And why don't we check our work to make sure? If we substitute in negative 3, we get 2 times negative 3 squared plus 5 times negative 3 minus 3. Negative 3 squared is negative 3 times negative 3. The negatives cancel out, and we get 9. And 9 times 2 is 18. 5 times negative 3 is negative 15. So we have 18 minus 15 minus 3. 18 minus 15 is 3, so we get 3 minus 3, which is 0. There we go. And what about 1/2? If we substitute in 1/2, we get 2 times 1/2 squared plus 5 times 1/2 minus 3. 1/2 squared is 1/2 times 1/2, which is 1/4. 2 times 1/4 is 1/2. So we have 1/2 plus 5 over 2 minus 3. 1/2 plus 5 over 2 is 6 over 2, which is 3, and we know that 3 minus 3 is 0. So both -3 and 1/2 are roots for this quadratic. Awesome. Now take a look at this quadratic. This quadratic has no real roots. If we take the discriminant, b squared minus 4ac, we get 3 squared minus 4 times 2 times 4. 3 squared is 9. 4 times 2 is 8, times 4 is 32, so we get 9 minus 32, which is negative 23. Since the discriminant is negative, this means that the solutions will not be real numbers. Since using the quadratic formula, you see that we'll have to take the square root of a negative. Now, this will produce answers nonetheless, but they will just not be real numbers. They will be imaginary numbers. But I'll save this for a later video. And that's an introduction to the quadratic formula. In this video, we've looked at how to derive the quadratic formula, how to use the quadratic formula to solve the roots for quadratics, and how to use the quadratic formula to determine whether or not a quadratic has real roots. The quadratic formula is super useful to know. You can use it to find the roots of any quadratic. All you have to do is plug in for the constants. And that's it for now. If you learned something or enjoyed this, hit like, subscribe, and share it with someone who's learning quadratics. Now, keep working hard and keep learning. Thank you so much for watching.